Athens Forge, our monthly meeting. And do we have new people here? I'm pretty sure we do. Raise your hand if you're new, first time here. Okay, that's great. We enjoy having new people. We are a member of the Alabama Forge Council. That being said, we require membership in the Alabama Forge Council for you to attend our meetings. Now, if you're here as a visitor, we invite you to come 3 times without placing membership. The third time, we request that you have placed membership in the Alabama Forge Council. That will give you a semi-monthly newsletter, the Bituminous Bits, a lot of articles and good information in that. You will receive that. The cost is $25 a year. So that's nothing. That entitles you then to be able to go to our 2 yearly events down at Tannehill State Park. Our Blade Symposium, which is in April, and then in September we have a Blacksmith Symposium. So keep those 2 events in mind. They are great events, and we have good times there and a lot of good food and friendships and things like that. Always cover safety first. Some of these guys get tired of hearing me talk about safety. That's okay. I don't mind you getting tired of me talking about safety. Please wear your safety glasses here. If you're in this area here, and we have safety glasses right over here in a bag, we require that. If you refuse to wear safety glasses, just step outside the door. That's all we ask, because we don't want you to get hurt. We would love for you to wear your safety glasses at home in your home shop. I see videos sometimes, and it just tears me up to watch some of these videos. But keep that in mind. Safety is our number one concern. We will have an iron in the hat today, and we sell tickets for that. We have tickets that are items that are donated. We choose, if your ticket is drawn, you get to pick an item off the table. That's kind of how we finance our operations here. T-shirts. Ashton, you want to say just a word about our T-shirts?
I'm doing sign up for T-shirts. If you want a T-shirt, sign up for it. Make sure you put down what full name, size. You don't pay today, but they're over here. We're probably going to do. It'll be a dark red or burgundy type color. It'll have a pocket, and I forgot to bring the artwork this time. So if you weren't here last time, you'll have to ask somebody that can describe it from last time. But it depends on how many we end up buying. The price will be anywhere from $16 to $18. So it just depends on the more we buy, actually, the cheaper it gets to a point. So sign up. I'll sign up this time, and next meeting will be the last time to sign up. So pass the word to everybody that in December, that'll be it for signing up on that. Also, I have a list of membership expiration dates over here. Judge just sent it out not too long ago. If your name's not on the list, it means you need to see Judge because you're no longer a member. And then iron in the hat. So
Okay. Good deal. Remember the T-shirt sign up. Like I said, you don't have to pay today, but we're just going to order enough T-shirts. We're not ordering a lot of extras this year. So if you want a T-shirt, please sign up for that. Travis asked me to announce that he has some Iron in the Hat tickets for the Urbana conference. I don't know what all is going to be in Iron in the Hat. I think there's a power hammer. There's some big items. But if you're interested in any of that, please see Travis. As it's already been mentioned, we're streaming live today, and we appreciate the efforts that are put forth for that. We've had a lot of good comments about that. So if you're not able to attend our meeting, go to Athens Forge, and you should be able to see it on YouTube. Is there anything I need to cover? I was going to make it quick today, but you know how I am sometimes. One other thing.
December meeting?
Yeah, December meeting. We'll have our December meeting. I haven't looked at my calendar, but it will be probably the same weekend. It will be probably an open forge. That
okay, that'd be the 28th of
Okay. You good with that, Travis? Yeah. As some of you know, they had a benefit for one of our friends down in Algoma, Mississippi, Mr. Richie Crew. I went over to it. I think Jeff Forrester here and John Paul went also. It was a very good turnout, a very good fundraiser for Richie.
He said it was humbling.
Yes, we, as you know, our group sent a little money down by me, and he was very appreciative of that. So everything was good.
Can you
Good turnout
catch us
down
up
there.
on what the problem is?
He's got cancer, and it's, I think,
Somewhere in this vicinity.
In this vicinity,
I don't know
yes.
exactly which cancer it is.
I'd rather not elaborate on that. But Richie's doing okay. The chemo kind of takes him down pretty hard sometimes, but Richie, he's a tough guy. Okay, if there's nothing else, we'll get started with our demo today. Mr. Mike Linn is going to be our demonstrator today. Mike is from the Vulcan Forge. Excellent blacksmith. I don't want to brag on him too much, but if you see him, he's got a bad back, but he's still here to demo for us today, and we appreciate that. He was supposed to have been here last month, and that back kept him down, but he's back going a little bit, and Mike has been the past chairman of our conference for about 6 years, I think, before Raymond Head took it over. So he's got the experience as a blacksmith of running a conference, and very knowledgeable guy. We're proud to have him come up today.
93. Been blacksmith since 93.
Since 93. So he's done a lot of classes, took classes, taught some classes, and been in a lot of classes. So he's learned a lot, and we're really excited to have Mike with us today. I'm not going to go in. I'm going to let him explain what he's going to be making today, and we're just going to turn it over to him at this time and anything he wants to say. One other thing, as I mentioned before, when we've got a demonstration going on, if you need to talk to somebody, if you need to answer your phone, if you need to tell somebody what Mike's doing up here, please step outside. Mike knows what he's doing. He doesn't need you trying to explain to somebody that doesn't know what he's doing. That way we can hear Mike when he's talking. When you get through your conversation, you can step back in. If you're in here talking, you see me look at you real hard, that means shut up, okay? Let's just be plain about it. If we can't understand that, we can't understand anything. But that being said, we're going to turn it over to Mike. Mike, appreciate you being here.
Thank you. Appreciate it. All right. This demo, it's a fairly simple set of processes to make a larger project that goes together. So it's something that a beginning blacksmith can learn to do using simple techniques to build a bigger project that gives you something that it's sort of a synergy. You've got more than the sum of its parts. And what it is, it's a nautical theme anchor to hang on the wall. It's got a ring in it to put your hand towels in say a bathroom, for instance. My bathrooms at the house have all got one in there, particularly the one that the wife did a nautical theme in. But once I learned how to do this, I started making them for the other bathrooms, and I've sold several of them. But it doesn't take a lot of material. Like I said, it's fairly simple processes. It's just in how you put them all together. The way I was taught is really there's only 5 operations in blacksmithing, and it's all in how you put those operations together. If you think about it, you've got the first one would be drawing it out long and skinny. Drawing out is your first one. The second one would be upsetting, making it larger and fatter. The third one would be bending it. Okay. Fourth one would be cutting, and I include punching and cutting in that it's a circular cut when you're doing it. You're actually shearing the edges, so I include that as part of cutting, whether it be with a hot cut or on a saw. That would be your fourth operation. The last one is forge welding. You put them all together. So there's those 5 operations, depending on how you put those together, gives you your project. So everything that Travis has done in here, all these fancy things that they've done, it's all the same processes. It's just putting them together in the right sequence. So the materials for this project are pretty simple. Most of it's, we've got 3 pieces of 3/16 by 1. So the first piece is 10 inches long. That's for the upright. The bottom flukes is 8 inches of 1 by 3/16. The cross member at the top is 4 inches. We've got approximately 15 inches of 5/16 round, and I'll get more into the lengths on this in a minute. And the last piece is 3/16 by half, and you don't need but just about 2 or 3 inches of that. I just got a little bit more than I need here to give me something to hold on to. Got some jigs that I use for doing this to make things simple, and we'll go through those as we get to that part of the step. But the first thing we're going to do is get this one hot. Now, I prefer typically to use longer pieces when I'm working this stuff because I don't like tongs. Hanging on to tongs is a pain. You never have the right tong. They never hold right. You never get the same grip as you do in your hand. Typically, I wouldn't have cut this off at home while I'm working this in. But to give you an idea of how much stock you really need, I did it this way. So we're going to get this hot. And the first thing we're going to use, the jig that I've got here, is a butcher. Who knows what a butcher is? All right, so we got several people know what a butcher is. Well, this butcher really is fairly simple to make. Just 2 pieces of channel welded together, and stick some business cards down in there with some regular old steel, just plain old, not tool steel, it's just regular mild steel. To make a butcher, you just take it and you cut it on the diagonal. When you reverse that, you get this area where you can come in and butcher in, is what that's called, that technique is called. And what we're going to do while that's heating up there is we're going to come in with that stock and we're going to butcher in like this to create a mass out on the end, and then we're going to draw this back into a long taper.
Get sparks.
Oh. That's what happens when you talk and blacksmith at the same time. Probably wouldn't hurt.
I know Dustin.
Dustin.
Flying back on Dustin.
What's up, Michael? Clean this up a little bit. We're going to forge this down quite a bit, so all this hitting is going to disappear. Learn how to use your forge here. And anytime anybody's got a question, don't hesitate to ask. Just, holler at me and I'll do my best to answer. So I'm going to pinch off about 1 inch. So I'm using it 1 inch stock, 1 inch wide stock, so I'm going to come back about 1 inch and pinch that off. Make that butcher mark. Now you got to pay attention to your orientation as you come in to make sure you're butchering the right direction. You'll notice I'm also turning it every couple of blows, re-indexing it. What will happen if you just keep butchering, you'll end up pushing in more on one side than you do on the other. If your blow's coming down here, say that's 100%, you only get about 30% coming back up the other side. So if you keep hammering on one side of it, you're always going to push more on one than you do from the bottom. So you keep rotating it to keep it even coming in. The other thing I do too is I'll rotate it on the 45 and hit, and that pushes those corners back, and it keeps them from rolling over and creating a cold shut. Yes, sir. Oh, that moves up. I didn't know that. I'm down here trying to look at it. Couldn't see. See, on the 45, I'm pushing those corners back in. Okay, so got that pulled back like that. We're just isolating that mass on the end. I need a heat about that long right there. A little bit about watching demos and watching the demonstrator. Every demonstrator has his own way of doing things. And one of the things I learned kind of early was to pay attention to what the demonstrator is doing. Not so much what he's saying, because a lot of times, if you've been doing this long enough, you already know what to do. And you've gotten to the point where you don't think about it anymore. It just happens by instinct. So watch the demonstrator's positioning, his hands, how he's holding a hammer, that kind of stuff. So I prefer a flat face square hammer, and there's a specific reason for that. Steel moves in the path of least resistance. So if I'm taking a piece of steel and I hit it with that peen, the metal's going to have a tendency to go this way. If I hit it this way, it's going to have a tendency to spread. Well, I get the same effect using the corners of my hammer. So I can be drawing out and I'm holding the hammer at an angle. So unless you're actually paying attention, you think I'm just hitting straight down. Well, I'm not. I'm holding it at an angle. I'm getting that fullering effect to pull the metal in the path of least resistance. But I can do the same thing with the corners. So say I'm trying to make something spread it out in a round circle, I could go to a round-faced hammer and get that spreading in all directions, or I can drop the hammer face and hammer in 4 different directions just by changing the position I'm holding my hammer face. So pay attention to the position of that hammer. When that hammer handle is below the face of the anvil, it means I'm moving metal away from me. When it's up high, it means I'm pulling metal back towards me. The other thing about hammers, a lot of people, if you'll notice, it's flat. My hammer handle is flat on the side. The reason for that is, without ever looking at it, I know how my face of that hammer is positioned, just by the feel of it. If it's a round handle, I have no idea which direction it's pointing. So I always flatten the sides, at least put a flat side on the handle, so that I know how that thing is positioned. So I'm just going to draw that back. So you notice I got the hammer handle up, which means I'm pulling back towards me. And I'm holding it at the angle that I want this taper to be. So I'm coming right up to the edge of it without hitting those corners, which takes a little bit of practice. The other thing you'll notice, for those that are paying attention, think about the power hammer right here. When it's hitting, what does it do? It hits the same spot every single time. It never moves around, on its base. It's hitting the same spot. The secret to hammer control is to learn to hit like a power hammer. You pick a spot on the anvil, and you want to hit the same spot on that anvil every time. And then move your piece underneath it, just like that power hammer does. When you're working it, you're moving that piece underneath the hammer. The hardest thing for new people to figure out is learning hammer control. Learn to hit where you want to every time. Well, if you're dancing all over the anvil, you're never going to get there. So the idea is to pick a spot. Pick a spot and hit that same spot every time, working your piece underneath it. The other thing I see is people not forging the metal. They're tapping it. They're hitting the surface of the metal. You don't want to do that. When you're forging, you want to move that metal. So not only are you picking a spot on the anvil, you're trying to hit that spot on the anvil. You want to drive through the metal to the anvil. That's the only way you're going to move it. If you just keep pecking at it. I was teaching a class last week at the Burritt Museum over in Huntsville, and they were drawing out. They were actually trying to what was it? They were making nails, and one of the guys was over there, and he's sitting there just tapping like this, just barely tapping on it, and he ended up with what we call a fish mouth. That's where the metal moves on the outside, but it doesn't move on the inside. And the reason for that was he wasn't driving through to try to hit the anvil below it. He was just tapping the surface. So it may be subconscious that you're doing that, but you're not moving the metal unless you're trying to drive into it. We'll draw this back just a little bit more. So you see how I'm moving the metal underneath? Regardless of, I may be moving around on the anvil, but when I'm striking, I'm hitting that same spot. Alright, so we've got a long paper for the end. Any questions thus far? Another aspect of the hammer is the length of the handle. I prefer a shorter handle. This is a technique that I was taught by Alan Kress down in Coleman and via Alan from Uri Hoffi in Israel. And it's to hold the hammer like this with two fingers. It's kind of a developed technique that you have to kind of learn. But if you're gripping got a death grip on that hammer and you're striking, you're putting that energy, particularly if you do the carpenter hammer and you put your thumb on top like that, you're driving that energy right to that joint right there, right where that tendon connects. And within a week, you won't be able to hammer anymore. So you got to learn to relax with the hammer. Let it flow. Let the hammer do the work for you. Let gravity work for you. Now, Clay Spencer, probably everybody here knows Clay. He prefers a longer handle, so he's got a lot, long strokes like this, so he gets a lot of energy. I prefer a slightly, smaller hammerhead. This I think is right at 2 pounds. Got a flat handle, fairly short. I hold it right here, and I snap it. So all that energy is just staying right here, and because I'm relaxed, it's not transferring up into my arm. So, and then when I really need to get on it, I can come up and let gravity do the assist. So what we're going to do now, is we're going to take our little blob out on the end. I've got this taper coming back this way now. And I'm going to round this up. And the way we round it up is we knock in the corners. So the first thing you do is go from square, you make an octagon, you make a stop sign. And then you knock those corners in. Then you knock those corners in. You just keep knocking corners in all the way around. And eventually it'll get round. Or at least round enough that your eye can't tell the difference. Now this is kind of like turning a scroll in a way that you don't want to hit the same spot twice in a row. Because if you hit twice in a row in the same spot on a scroll, you're going to get a flat spot. And your eye will be drawn immediately to that spot. So, same thing here. You don't want to hit the same place twice in a row. So I'm going to come down here and I'm going to drive that in. And I'm changing my position a little bit each time. And I'm rolling it. So see, I'm knocking those corners in. Basically what I'm doing is I'm doing that upsetting that I was talking about earlier. So I butchered in here, which would be a form of cutting, but these are really dull, rounded off. Reason for that is you don't want a real sharp corner right here because it'll break off. Any of those, particularly an inside sharp corner, is just asking for a crack to happen. So these are really rounded off so that doesn't happen. But this operation is upsetting. So I've cut, I drew out, and now I'm upsetting. Any questions so far? Supposed to be an interactive activity.
Would you do that butchering operation on the edge of your handle if you don't have the butcher?
You can. I've done it before, but you have to have very precise hammer control to do that because those notches need to be in exactly the right places. Otherwise, if you're off a little bit, it's not going to look right, and trying to fix it's going to be a problem. But these butchers, if you can get to a welder, you can, scrap metal. I've probably got a half a dozen of these around the shop of different sizes and styles, depending on how I made them. And that's one of the problems is that, unless you're consistent, like using this one here, where you build a Smith & Magician, which I just got one just at Tannehill. I don't have enough stock to fit everything, so I've got I got like 5 of different sizes. I use different size material. So I'm slowly converting to a Smith & Magician where I can get a big bar stock, and then I can start making them to fit one, and then I don't have to have half a dozen running around the shop. But you can make them like this. I've made some that are sort of a clamshell kind of mechanism where you just got a bar on the bottom and a bar on the top on the edge, and then you're hinged at the back so that they can snap together like that. So we'll go ahead and round this on up. Constantly be going back to the fire and straightening up. You get too far along and you can't fix it anymore. I've got it fairly round. I've got a little wonkiness here or there, but I'm going to fill that in by using a hammer to push metal from the middle out. So watch how I hold the hammer as I'm pulling that metal around. And if I start sounding hoarse, I apologize. I just took my pain meds and it's making my throat dry. Out. Notice I keep my left hand moving. I'm pulling metal out. Trying to get enough metal to round it up good. this is what's called a penny. You'll see them on a lot of different things. Penny scroll, is a good example of that, where typically you have a penny that's off to one side and it becomes the beginning of a scroll. So this same technique is used to make any size, penny, or I think in the older parlance is a halfpenny or a half penny from England. It was the same size as a half penny. So our next operation is going to be punching, which I told you was circular shearing. So one thing I was taught was you don't want to strike hardened tools like a punch with your forging hammer. If you strike this hard tool, it's going to put marks on the face of your hammer. And when you strike down on a piece of work, you're going to transfer that dent into the work. So if you got dent all on your face of your hammer and you strike down, you're going to leave those marks all in your work. So I remember we had a new guy show up at Vulcan Forge, and he had this brand spanking new Eddinghaus hammer that he bought. Just was proud as all get out of it. First thing I did was take it away from him and go to the belt grinder with it. Start grinding the face down. Because when you get a new one, it's going to have sharp edges on it. You want to take all those sharp edges off. Unless you're trying to cut, you don't want sharp edges on any of your tooling. On a punch that you're going to be using for punching holes, you want a taper, but you want a good sharp flat edge. You want fairly sharp edges on here. I mean, they don't have to be like razor sharp or anything, but you want good clean sharp edges because, like I said, we're cutting circularly. The idea is when I'm punching, you'll hear it bottom out as that metal's shearing and squashing underneath it. You'll hear the sound of it, and then all of a sudden you'll hear a change in the sound. And that's when you've bottomed out and you can't go any further. If you hit it again, what's going to happen is you're going to mushroom the bottom of your punch because it's hot. And it's going to flare out and it's going to get stuck in the hole. So you have to be careful about that and listen for that change in sound. Then when I flip it over, you'll see a mark where I've bottomed out against the face of the anvil. Usually it'll be dark and it'll have a ring around it. That's going to be my mark for going back to punch from the other side so I can line it up and get a good shear on that flattened area on the inside there. Now also when you're punching, this anvil's nice that it's got different size holes that you can use. Because what you want to do is you want to support that material around the hole so that you can get a shear. If I tried to punch in this big hole, the whole thing would just disappear down into the hole. So I want something that's going to support around that. Now if you don't have an anvil that's got a hole like this or a fairly small pritchel, what you can do is make what's called a bolster plate. And it's really just a plate that's got different size holes drilled in it. You want to kind of chamfer those edges just a little bit, but if you punch different or drill different size holes in there, then you've got a size for whatever size you're trying to punch through. So put that here. Okay. This is where the third hand comes in. I'm going to punch right dead center here. Notice how I set it and then I'm resetting. I don't keep punching and just flaring away at it. You hear the sound change? There's our mark. Come over here, line up over that hole. So as you can see, I've got that little plug still attached. there's our little plug that we took out. It's gonna be hot, so. But really, what you want to see a good round plug that comes out of there. So now I'm gonna open this hole up a little bit. And that's where the cone mandrel comes in. These are, I think Laurel makes these. I bought one several years ago. I think they were $75 back then. Really nice to have one in the shop. If you get a big one at a good price, I suggest you get it because it will always pay your money back with interest usually. If you don't have one of these, you can make something similar. A Bic can serve the same purpose. I've got one that I made out of a jackhammer bit, where I brought it in here, heated up, bent it over, so that I could work it like that. But it's tapered. I tapered it with a grinder to give me a round Bic that was coming this way. One thing to notice that's different about the horn versus a cone. The horn typically is going to be flat on top. It's going to have a flat side to it. It's going to be tapered around here. It's like a cone with one side sheared down. So if you're really trying to get something round and trying to work it round, use the cone. Now, the only reason I'm using this cone is because this horn is too small on the end. So I'm going to use this to get it going, get it open wide enough that I can fit it up here so that I can open it up some more. So again, keep going all the way around. And what you're doing is you're using the inside of the cone to open it up. And you want to reverse every so often because the cone is tapered. And what's going to happen is it's going to start pushing to one side out of the middle because of the way you're forging here. It's going to try to push upwards, and this thing is going to try to rotate on you. So you want to keep rolling it over as you're doing that.
Why can't you just use your punch to just make it bigger?
You can. That's another way to do it. I'm trying to show a couple of different ways to do it, and I'll do that here in just a second. I'll open it up some more. If you've got a good bolster plate that gives you the support you need around it, then you can use a punch and a drift to open that up. I've got this permanently mounted in the shop next to the ammo, so I can just reach over and just do it. And I don't have to worry about doing anything like that. Plus, you have a tendency to get a belly when you're doing it. Unless you've got really good support around the hole, it's going to tend to push inwards and down with the hole. And I'll show you that here. We use this punch. I can get about that far in it. And if you go too far, you will get that thing stuck and might not be able to get it out. Okay, I got it apart. So I can come up here as well and open that up. And again, you don't want to keep going from the same side. You want to work this slowly. Push it back, working from both sides. So there's more than one way to skin a cat.
And we're banned on YouTube.
So typically when you're punching holes, like Travis has done, like they did there on that ring, you're going to use a drift. You're going to punch the hole, whether it be round or square or diamond, and then use a drift to drive through and open that up. And you got to be real careful, again, working from both sides to keep everything even. And if you just work for that one, it's definitely going to push away from you, go into that path of least resistance, and get out of whack on you. thing you have to be careful of is where it's been necked down. If you keep working that back and forth like that, where that narrow spot is, it's going to want to break off. So you want to leave enough heat in there at the end before you go back to the fire, because you don't want to be forging that cold and have it break off.
How do you know that happens?
What's that?
How do you know that breaks off?
Because there's a pile of them behind the shop. Comes with practice, just kind of knowing when. It's hard to teach new people when to quit. They're always getting hammered on, the teachers are telling them, get hot, get hot, get hot. Okay, so that's about all we need. Now, for some of those who've been around a while, you might recognize this shape. This is the first step to making a bottle opener, with a church key bottle opener. So that same technique is used on this. So if I cut this off right here and made, say, a rat tail, pull the little lip out in the middle, I've got a bottle opener. So on this one, I'm just going to, the other end, I'm just going to heat this up a little bit, and I'm going to knock these corners off. Mine does that. Alright, so I'm just going to knock these corners in, just because I don't want any sharp edges. The other thing you want to do is you want to work the edges and planish all these edges off. You don't want any sharp corners on any of your work. I guess the word is chamfer. So this is the first step. That's the upright piece for the anchor. We'll set that one aside and cool. Next, we're going to do the flutes. And again, this is a piece of the 8-inch of the same material. It's 1 by 3/16. Probably about 2-3 inches of it. We're going to go back to our butcher, but this time I'm going to take the bottom piece out, because I only want to butcher from one side. What we're going to do this time we're going to come in and we're going to butcher like this. Okay, we're going to just butcher from one side. Instead of coming in equally, we're going to butcher from the one side. Well, let me start over. I missed a step. First step, we're going to take that bar just like this, and we're going to forge an angle back like that. We're going to upset and forge an angle. So eventually it'll look like that. Then I'm going to butcher in here. So that's the first step, and then the second step will be the butcher. Right, so when you're forging an angle, you want to go all the way to the edge of the anvil and hold your hammer at the angle that you want. And it's going to want to try to roll on you when it's this thick. Unless you're hitting perfectly, it's going to try to roll. So you got to keep flattening it back out. On. It's getting down in my eyes. Didn't think it was that hot today. I have a whole drawer full of these things at the house. In the summertime, I'll go through about 5 a day, hanging them up to dry and then reusing them. Now you can see why I prefer to hold this instead of try to use tongs. The idea is to keep the same thickness all the way through. Alright, so we're drawing that down on one end, like that. Any other questions so far?
How many knives you made?
Huh?
How many knives you made?
I've never made a knife in my life.
Oh, really?
Been doing this 26 years, since 93, however many years that is. Never made a knife.
26.
Yeah. So,
Did you do the angle to put mass in the end instead of just cutting it with a chisel?
well, you could do that. It just, I don't know. It's kind of a pain to try to hold it and cut it and do all that. You could grind it off. You could cut it off with a saw.
You just need the angle.
You're trying to get an angle there. And like I said, I'm trying to keep the same thickness. So it's practice. You know, it's good forging technique and practice to be able to upset something that thin. You know, it's one thing to upset a piece of 1 inch that you're banging on. It's another to upset something that's real thin that's wanting to roll on you all the time. So it's good practice to do that. And you know, you saw that I kept having to go back and push that back over because it was wanting to roll on me. All right, so now we're going to come over here to the butcher. And I'm going to butcher this way with a flat just past the edge of that. And again, it's trying to roll out on me, so I want to keep flattening that back. See it tries to roll, it tries to twist, it tries to do all kinds of strange things for you. Tool department. A pair of, I call them vice grips, but they're not made by Vice Grip. They're Grip Lock is the name of the company. I just happened to stumble across these at a yard sale one time. But what I liked about them is, when you're using vice grips, you always have to adjust that screw on the back. Well, these, no matter what size stock I'm using, it automatically adjusts to the right size. So, I'm going to try to pick up something big. So no matter what size it is, all I have to do is pull back on this little piece right here, and it automatically adjusts. So if you ever run across them, let me know and I'll buy them. I love those. That's the only pair I've ever found.
That is awesome.
All right, so I'm going to draw this back now a little bit. I'm going to get that same thickness back out there. Off there just to make it look right. And again, this is just an aesthetics thing. It's nothing to do with, I'm not trying to build a crane or anything like that. It's got to be dimensionally perfect. It's just something that looks right to the eye. You may have heard the term the essence of. It's the essence of a flower. It's the essence of a horse or whatever. It's whatever you see in it. But certain things just look right to the human eye. Like I said, a scroll that's got a flat spot in it, your eyeballs are going to go right to that flat spot immediately, and everybody's going to see it. Now, the little bit of a warp or the nick in it or something like that, only the blacksmith in you is going to see that. But a good, pleasing scroll is really nice to look at. So this is the other way you can forge it if you don't have a butcher, is to put it on the anvil at an angle like this and hammer into it. Okay? So you can get that same effect doing it like that. The key to this is you got to get a really good set first so that you have something to index to. Because if you just hit it and just start wailing on it, you're going to start bouncing. And you'll end up without being in the right spot. I prefer that because I can hit it, I don't have to worry about positioning and all that. Once I get it set, I don't have to worry about it anymore. Brought to show. Probably all heard of a hot cut hardy, right? For cutting off hot metal on your anvil or in the vise or whatever. Well, this is a hardy with a safe on it. Particularly for new people learning how to hot cut without cutting through and hitting the hardy underneath and either marring your hammer face or tearing up the hardy. This is, it takes some practice to learn how to do that. So came up with this thing called a safe, and what it is a hardy that's got two stop blocks on it that are just above the edge of it, so you can hammer down and hammer flush without having to think about it, and you still got that little bit of webbing that you need to hold it and then break it off, and it's not going to go shooting across the shop. So this was thought was a pretty cool idea, and I don't even remember where I saw the idea.
Probably from a nailer.
Yeah, there's no telling it. I've had this for 20-something years, but I haven't seen another one anywhere. But so I thought I'd bring this and show you. You can pass it around if you want to. But like I said, it just leaves a little bit of gap there, so that you've got the webbing that you need without cutting into the hardy and damaging your hammer face. So what I'm going to do here is I'm just going to sharpen this edge up a little back here. Give it a fairly sharp edge, a corner I should say. Get it all the same thickness, get it all straight. Okay, so that's what we end up with. So now I'm going to do the same thing on the other side, only this time I'm just going to do it, I'm not going to stop and talk about it. Main thing that you got to worry about on this is making sure you get your flukes pointed in the right direction. I've got a pile of those in the back where the fluke is on the wrong side. And this ain't one where you can twist it and make it right. You know, if it's in round stock, you can twist it and hide it. Sometimes in flat stock or in round stock, you can hide it. Or square stock, I mean. But in the flat like this, there's nothing you can do but throw it away and start over. So make sure I'm pointed the right direction. Actually, you get a smaller pair of tongs. These tongs, and I don't even think they make them anymore. They're off-center forge. They're made for holding flat stock. They're 1-inch box with just a thing on top. I think there's other people making them, but do they still make this style?
Yeah.
Okay. I love these. These are made out of 1045, so they're strong. They're not hardened, but they're good and strong, and they're springy, and they're light. That's the thing I love about them. They're light. You know, if I'm doing a lot of heavy upsetting, then I might want a heavier tong. But just for general holding, you can't beat these. They used to sell them 5 for $100, but I don't think they sell them for that anymore. But I've got a pair that's smaller because I forged that down at that end. It's not a full 1 inch, so it's harder to hold on to. So make sure my angle's right. Forge that. Another thing that I was taught was leave enough heat at the end of your forging cycle to make any corrections that you need to do before you try to go back into the fire. So you want to get everything back straight if it needs to be straight, you know, whatever you need to do to get things back to where it needs to be before you go back into the fire. Now, the problem I'm having with these tongs right now is that the point's wanting to come off to the side. So I'm going to change up a little bit. Now I've got 2 sets of tongs here to hold the same size material. Now if I was going to grab the material, say in the middle of something, a little wide. If I needed to grab it up in the middle, these are great for that. Comes in underneath it like that. But in this case, I need something to push against. So it'll be able to push up against the back of the hinge because it keeps sliding out on me. Well, yeah. Dang, I didn't have this much trouble with it before. will have to go with these. But, yeah. Alright, so I'm holding that tip just to the edge of the anvil, and that's so that I can get there right down to the end of it without hitting here, because if I was trying to get back here, I'd be hitting the top of the anvil face. We bring it right to the edge, and that way you can get right down to that little tip. And again, if you got any questions about what I'm doing, why I'm doing it a certain way, just ask away. Okay, yeah, just that's fine. The hardest part of doing these demos is trying to fill in the dead spots in between the heaps.
Normally people just make Dustin do a song and dance.
There we go. That'll work. Okay, so we're back over here. I've done just past it.
Butchering in about half, or what?
Probably about 2/3 of the way.
Oh, okay.
Just eyeballing it. Main thing is you do one and then you want to match the other one to that one. So it's not super critical, but you know we all know in our head what the fluke on an anvil or an anchor looks like. So you know you expect a certain amount of cut there where that fluke is, or where the end piece is. So it's just, you know, it's up to your, whatever you like. So this is what we were talking about earlier, coming in and hammering like that. But you can see it tended to want to come in. I think I went a little bit too far. I did pull that out there. That's what happens when you change the way you were doing it. Because it was a little hotter than I thought it was, so I went further than I wanted to. So I'm going to match that one to this one now. One of the things you might end up doing, though, is if you keep doing that kind of stuff, is chasing your tail. Now, okay, I went too far with that one, not too far with it, and you end up back and forth. So eventually you have to pick a stop point and just stop. Say, I'm done.
Can you hold it like how you were just holding in front of that camera for me? Gives it a chance to focus.
Okay. Move it around too much?
Yeah.
So, that camera?
Perfect. Thank you.
All right. I'll just pinch that one off just a little bit more to match the other one. So it's a little thin there, so I'm going to have to be real careful not to break it off when I go to bend it. got the back side a little boogered up. So I'm gonna. Now one of the things I've learned, you can learn a lot from watching somebody fix a mistake. Okay, so I did make a mistake here. So when I came down here, I moved a little bit, so it indented a little bit. So what I'm gonna do is I'm gonna heat it up, and then I'm gonna quench the tip, leaving that back side of that flute hot. That'll allow me to forge on the tip that's sharp, but because it's cold, I'll be able to forge it. I'll be able to flatten that back out on the back side of that. So now I can come in and do this and use the back side of the sharp spot on that anvil to fix that up a little bit. I can also come in here with a file or a grinder and fix it. Alright, so now this is where we're at. You can see. So now I'm going to curve it, give us our curvature. So I want the whole thing in the middle hot, basically. Flute. Any other questions? Just a lively bunch today. Y'all get your coffee?
You do such a good job of explaining it as it goes along.
Well, like I said, I've been doing this long enough that a lot of it's become second nature. I don't think about it. So I have to kind of step back to somebody who hasn't been doing it long and say, okay, what is it that I'm doing that they may not understand or may not see, may not recognize right off the bat? Stuff that I picked up over the course of 26 years of doing this. So, now what we're going to do is we're going to use the horn to start bending this. Now the problem, if anybody's ever used the horn before, they know it's tapered. Well, when you try to bend, it tries to corkscrew on you. I hate toms. All right, the trick to bending on the anvil in particular is that when you're bending material, that material has to have a place to go. You have to have space underneath for that material to move into. If I hit and I hit here, I'm not bending, I'm forging. I'm pushing it against the anvil. To bend, I need space, some place for that metal to go to. So when you're up here on the horn in particular, like I said, it's tapered, right? So wherever I'm going to be bending at, I want to pick a spot that's 90 degrees to that spot, okay? So if I'm sitting here and I'm in line with the axis of the anvil this way, it's going to have a tendency to turn because I've got metal on this side that's not the same distance from that side. So it's going to twist away from me because there's space there. So you pick a spot on that horn that's 90 degrees to that individual spot. If I move up here, I've got to change my positioning because it's a continuously changing angle in most angles. This one's fairly straight, but most of them kind of rounded and they kind of do this. So you have to look at that spot and figure out what's 90 degrees to right there. And then when you're bending, you want to stay on that angle to keep it from trying to twist on you. And it's still going to want to twist some, but that'll help reduce the twisting and corkscrewing that you get. Bending this thin stuff, it really wants to roll over on you. But if you notice, I don't know if you can see, but I'm hitting out into empty space. I'm giving that material some place to move to. All we're looking for is just a good, arc, particularly across the bottom. When your flukes are up like that, you want a good rounded bottom. The top is going to be a little bit straight, because what's happening when you're bending, if you think about it, the bottom that you're turning into is compressing and upsetting, whereas the outer side is stretching. So you always want to keep that in mind whenever you're doing any kind of bending or scrolling like that, is that you're compressing on one side and stretching on the other. So in this particular case, the way this is, the width of this material, that's going to manifest itself as a kind of a smooth curve on the back side with it more flat on the inside. And that really doesn't matter. I mean, it's just looking at your eyeballs. Now, I want this even. So I'm going to use the vise just to get everything squared up. Man, I wish I had a vise inside. All right, so we got us a smiley face. So we've got the bottom of our anchor here, like that. All right, next piece is just a 4 inches of that same 3/16 by 1, and that's what we're going to make the crossbar. We're going to make it. It's going to look like the old-fangled barbells, the weight barbells. Going into that hot. Probably the whole thing's a bit hot. That's fine. This is the same thing we were doing before with the upper piece. I'm just going to come in, I'm going to pinch off on each end, pull that out in the middle and round up the ends. So I'm going to go through this pretty quickly as I can. Again, we're going to pinch off about an inch. Maybe 3/4 inch. straighten things up as best you can before you go back in the fire. Be surprised how handy pickup tongs are. A lot of times you hear them called rivet tongs.
Let's see.
I didn't bring my other ones, but I got another pair that got really long tips, and they're great for when you got to pick up little things like rivets and stuff that may have fallen in the fire, or stuff that you can't get down in there like that. But you wouldn't think that they're all that handy, but they come in really handy. I told you that I hate tongs.
Well, as much as you hate tongs, you know, it makes great YouTube content if you just try to do it with your hands.
Yeah.
I mean, just a thought.
It wouldn't last very long, that's for sure.
No, but we'd go viral instantly.
Yeah, look at that dummy.
You gotta think of the greater good here.
Anybody watching?
Right now we have 12 people watching.
Right.
Some people up in Indiana, Georgia.
Right. I was just thinking of something I was going to say. And I can't
People in
think of
Minnesota,
it. There we go.
Michigan.
Dang it, I just had something on my mind that I was going to say it. I can't think what it was now. Draw that back some more. I made my stop sign. Now I'm going to round it up and spread it out some more. Questions? Comment?
Alfred McClure says hi. You're doing a great job.
Hey, Alfred.
And Mitchell Perkins watching in Wetumpka. Says hi.
Cool. There you go. Probably can't see it, but I'm working out from the middle out, trying to pull it into fill in the holes where it's got flat spots. Keep the other end this time. A lot of people teach, I shouldn't say a lot of people, I know one instructor down in our area that doesn't let his students wear gloves and has to teach them how to handle a hot metal. Because when you're wearing gloves, you can get complacent about things a lot of times. I prefer to wear one on my right hand, on my left hand, just for the shock, you know, holding the tongs and little pinches and stuff like that that you get from different things. I do have my pair of the right here, the Kevlar for holding hot stuff. That can, if I need a little bit shorter and it's getting hot on me, but I don't want to try to quench it, I can wear those. I don't wear them a lot. I typically tend to stay with these. Thing is with leather is that when they get hot, they're going to stay hot unless you cool them off. So once you start feeling that heat, you better come out of them pretty quick because that heat's going to get you. Okay. We're going to come over here and we're going to pinch off the same amount that we did over there. I didn't bring all of my tongs. I tend to bring too much stuff, usually.
Said no blacksmith ever.
But it's amazing the number of tongs you collect over the years. I got a rack of hammers and a rack of tongs. And thing is, I probably, I'll make a pair of tongs for one specific job and I might not touch them again for 10 years. The thing about off center is nice is they mark all their tongs for the size. So by doing all this, knocking these corners in, I've upset it so it's really thick. So that's what allows me to have the metal to move wherever I need to. Like it's kind of flat on top, so I can push metal from the middle up that way to help get that round. But first, to give me a little bit more working space, heat this up in the middle. So yeah, I highly recommend those off-center tongs. You said Kane and Sons was the one?
There's Kane and Sons, Blacksmith's Double. They've still got
Good deal.
not cheap anymore, Mike.
Nothing is.
Not exactly. You've got those $20-25 tops.
Yeah, it's 5 for $100.
Yeah.
Yeah.
Now they're like more like 3 for $100.
Wow. I think they were $25 a piece, but if you bought 5, you know, he gave you a discount on it. So what I'm doing is I'm squishing down this middle area. Probably working this smaller stuff like this, when you get on the anvil, it really cools fast. So you've got to be thinking ahead of what you're going to be doing, what your actions are going to be, you know, which way I'm going to turn. Think about, okay, this side needs to be up or down, or all that's got to be going through your head at the same time as you're tending the fire, as you're doing all the rest of the stuff. So there's a lot of stuff going on in your head. Travis, you got a small swage block with a like a 3/8 3/8 fuller. Swage in it, or just a die. I started to bring mine, but I knew you had one, so. Yeah, that one right there. That's exactly what I need. That's what I got at home.
Travis. A little bit closer.
Can you make any more noise? What I'm doing, I'm knocking these corners in somewhat as I'm drawing it. The idea is to squish this down, get that barbell shape. Hang on to this stupid thing. You'd be surprised when you squish that down how long you can get this when you're taking that material, even though it's thin 3/16, pushing it down, there's a lot of metal there. So it has a tendency to draw on you. So that's why you only need 4 inches to start with. It doesn't sound like much, but when you get through, it'll be, you know, a little over 6 inches long. So let's see. We need actually that one right there. So this is a Lawler Foundry swage block. I think they're still making these and selling them. Same way with the cones. The same place. They're over in Lawler, Mississippi. And you go to Lawler Foundry and order them. I'm wanting to say these are, what, about $225 maybe? Sounds about right.
I have no idea what you think farm is.
Yeah, I don't know.
What did you say it was?
Lawler Foundry.
What's
They
that?
They have an ad in the bits every month.
Salt Forge making
Lawler
some.
Lawler.
Lawler
in
Foundry.
Mississippi?
Yep.
Where's that?
Holland Animals making some nice
Where?
ones, too.
I mean, I can look it up, but I thought.
Lawler, I think, is not too far from Jackson, but I don't remember for sure. It's down in that vicinity down there. I'll straighten that up a little bit. This is the slowest part of watching all this. It's just all that dead time in between. I know at Tannehill during the conference, you look up and there's, you know, particularly about, excuse me, this time after lunch, excuse me, about 2 o'clock after lunch, you'll see about half of the front row is just snoozing away. You got that big bellies full and they're relaxed in their chairs and they crash and burn.
Or to get the old one.
Yeah. Alright, so again, I'm pulling material out to form that penny. Keep that gosh darn moving. Alright, so I like this anvil. It's got this taper back here. When my anvil at home, it's actually a little wider, and it's not until I get somewhere about 5 inches that I can get both leaves off, or both of the pennies off the edge of the anvil. So it makes it tough. Sometimes I have to work inside the table, which this one doesn't have a table, but it's got this narrow section back here, which is really nice.
Well, just take it home if you mind. Travis
Yeah,
will
well,
mind.
y'all load it right up and I'll take it on. He'll never miss it.
Yeah.
All right, we're going to take the one more heat. I'm going to forge that down just a little bit more, and we'll be done with that. And these next 2 pieces won't take very long at all. here goes the swage block. So anybody that's not familiar with a swage block, you've got, if you look at it, you've got a lot of different sized slots. These are round slots. You get some over here, like they'll be triangular and square slots for doing what I'm getting ready to do here. They have dishes in them for doing like ladles and spoons and different things like that. They're real handy and nice to have in the shop. And the design of this stand, and I've got one very similar to this, that allows you, no matter how you set this in here, it's always basically at the same height. Mine does. I've got one where I can set it like this and keep it in there. I've got extra ears in there for mine. That's the idea on a swage block. So I'm going to take this and I'm going to just drive it right down into this swage. What that does is give me a rounded front with a flat back. And it helps draw it out some more as well. I've got another little tool called I guess I'd call it a cupping tool. And basically it's just to give a sense of depth to the end of those balls so they look like they're balls out on the end of it instead of just discs. By giving it a sort of a three-dimensional look, just makes it, give it depth or a sense of depth. But this is just a piece of pipe that's been, I rolled the edge out a little bit, so I don't have, it's not straight up and down. They're kind of rolled out like this. And that keeps it from trying to cut or shear those edges and leave marks. Oh. So what's cool, now, I don't know how many people know, but ball peens work as a great struck tool as well. Not only are they a good hammer, but they work as a good tool like this. Anybody knows Clay Spencer, he buys every one of these he can get his hands on and then forges tools out on the end of the ball here and then uses this as, puts the handle back in it and uses them as a power hammer, the treadle hammer, or as a struck tool. So if you can bring that out, just set the cup right there in the middle. Just like that. And we're going to set that in the middle of that. Drop that down just a little bit. There you go. And I did it the wrong way. But guess what? We can fix that. I wasn't paying attention.
Justin's fault.
Is that what it was? Yeah. Hey, what are you doing?
I'm sorry.
I can't help it.
I wasn't looking at how it was sitting in there. So next time, do this round side, put that up.
Oh, we know you did that to make a point for us. That's right, teacher.
So yeah, you want the rounded side up. Because what it's going to look like once it's put together, it's going to look like a bar, a round bar that's there with two balls on the end of it.
Rounded side up or rounded side down? Rounded side down, Mike. Rounded side down, shouldn't it?
No, because it's going to rivet to the front of the back plate. So this is what the finished piece is going to look like.
Yeah, you want the rounded side down.
Right? What am I thinking of?
Very nice.
Now, see, I can blame it on medication.
Oh, do you make mistakes too?
No.
You're just reinforcing what you said earlier, Mike, that we can learn a lot from mistakes.
That's right.
That was planned.
Sure. We'll go with that one. The same thing to the other side. But again, that's nothing, just a piece of pipe. Now it was actually a piece of pipe that I was playing with, trying to do some different forging, playing around with it, and it just happened that as I was messing around with it, I folded it down onto itself, so that's why it's got that seam in the middle. That wasn't there for any particular reason, but it just happened to work that way.
What do you use to weld those pieces together?
Just a wire welder.
Okay,
Yeah, just a bzzz.
thank you.
You do it with a buzz box. I still got my AC buzz box at the house. I can't think of the last time I ever turned it on. But I've got a Miller-Matic AC, the 250 amp MIG welder. You got that pointing in the right direction? I think so. Back it up just a little bit.
If not, we can fix it.
Yeah. This is one of the few things you can fix. Okay, so there's the other piece. Cross piece. Alright, the next thing we're going to do is do the ring, and that won't take but just a second. So, 5/16 round. It's typically what I use. You could use 3/8, but it's a little big for what you're using it for. It doesn't really matter. It just looks hefty on the compared to the rest of it. So this 5/16 works good. I'm using 15 inches, and I'll tell you why. Because my jig uses 15 inches. So I don't have a big comb mandrel. Where the hell? I saw one in here, right there. I don't have a big one like he's got. All I've got is a little one. The problem with comb mandrels is that you see they're tapered. So when you try to turn a ring, they want to taper themselves. So what I've done is I found pipe of different sizes, wall thicknesses, and I've got probably 30 of these in the shop, ranging anywhere from as big as my little finger up to 18 inches diameter. I just cut a slice out of them, weld them to a piece of angle iron, and I can chuck it up in the vise and use it as a form to turn something to. So everything is different sizes. Now this one's a piece of pipe. This one's just a little bit smaller, but I made it after turning it around something else and cutting it off and welding it. So you can use one to build up a whole bunch of them with little steps in between depending on how thick your material is. So I've got all kinds of different sizes, and I got a gazillion of them laying in the shop for different things. Particularly they're good if you're trying to do a lot of one thing. If I'm just making one of something, I'll typically do it by hand. I might do two, but if I'm going to do any more than two, I'm going to make a jig. That way I get consistency. I can make them the same way each time and don't have to worry about trying to chase my tail, trying to make everything alike. That's one of the hardest things to do, is make two things just alike. So which vise would you rather me use, or does it matter? I think the vise is in the frame, is it?
Yeah, it is.
Okay. The way I use this, I get a pair of these needle nose vice grips and I grind the teeth out of them. And that allows me to get in pinch it. So you can get down into the narrow, the smaller pieces of pipe with these little vice grips that are. And if you don't grind the teeth off of them and round them up, they will leave the teeth marks in your material, especially when it's hot. So that's the first thing I did was I'll grind the teeth down and then just round them up so that you don't leave any marks on there. So another way you can bend, if you've got an anvil that's got a step in it, it goes from the face down to the step down to the horn, you can use that step and holding your material this way. Again, when you're bending, your material has to have some place to go. So you use the top of the horn and the edge of the face, and you forge down to the end of the step, and that gives you that curvature. You just work it around a little bit at a time. Another way is to use forks. So you've got, I don't know if you can see this on the camera, but you can put the material in here and bend them like this a little bit at a time. I do a lot of stuff like this cold. This combined with a handled fork. You got a handled fork around here somewhere?
A bunch of them there on the wall, just right there.
So I love these kind of forks. I've got a couple like this that are forged out on the end. I've got some that are more like an F shape that you can use. But you take that piece of material, you stick it in here like this, and then with using a combination of the two, you can bend all kinds of things. So these forks come in really handy. And you don't have to have something fancy like this. What I've got at home, I've got a bunch of pieces of spring that I've bent into a U, and you can stick the U in the vise and use that as your bending fork. So I've got a bunch of different sizes of springs with different gaps for different size material, and the spring is good and strong, so you don't have to worry about bending it. Grab it right by the end, then that jokes around. When you're bending, you always got to be pulling towards you, because it's going to want to pull away from it. I don't want to hit too hard, just tapping it in good and close. So that gets most of it. So all I want to do is I'll stop shy of there. If I try to bend anymore, it's going to pull away where that cool transition point is. So you want to stop just shy of where that heat stops. Because again, if I try to bend here, it's the least resistance is going to be back here where it's hot. So if I try to bend this is going to pull away, and it won't be round anymore. Anytime you're bending, whether it be something like this, a scroll, and you have to take multiple heats on it. You ultimately, in a perfect world, you get one heat and get everything done at once. That almost never happens. So you end up having to take multiple heats. Well, when you do that, you want to make sure that you've got a heat overlap. So if you heated this section, you stop shy so that it doesn't pull away. Now you want to heat this next section, but you want that backside to overlap where you stopped, so that you got a good continuous heat zone all the way around. So that keeps you from having those positions where they pull out away from it or get wonky on you when you're using a jig. And that's just stuff I learned from experience, you know, trying to do it, and it's like, well, why has this got this weird spot in it? Well, it's because I didn't get that heat good in transition past where I stopped the first time. Now another way that you can use is bending forks. This is a F type that I was talking about. Is you can come in like this and use it to pull around, tighten things up, and then hold it, and that'll pull that thing good and tight while you're letting it cool against the jig. So I'm just going to let this cool just enough so it doesn't spring back when I let go of it. Now we've got a ring. Tap it a little bit. Now it actually helps on some things when you're doing a door knocker, for instance. I had one that I did where the so there's our ring. Where it had kind of a wide piece right here. Well, if it's curved and if your holes or your space in there isn't big enough, it's going to bind. So sometimes you may have to put a flat spot right where it's going to go in through that hinge portion. So that's just something to think about, you know, as you're designing work or looking at things, you know, how does the physics of that work inside there. So a lot of times you'll have to just tap it right there and give you a little flat spot. Okay, the last portion is our hinge piece to hold the ring. And this is pretty easy, especially with this jigs I made. So again, it's a piece of 3/16. This is a 1/2 inch. So you only need just a little bit of it. And what we're going to do is we're going to make an offset. Where did I sit that chart? So we're going to have it come in like this, and then we're going to have an offset like that, so that the end of the ring can fit in there. Okay. And I tried every kind of way known to man to make one, and none of them worked until I came up with this little jig. If you can see it on your camera here, it's lower. So that's all the jig is. It allows me to bring the metal in like this, and it gives me that offset. So this is 5/16 right here, and that gives me the correct amount of space for that ring to go in there. So that's why I say on this, the 5/16 is optimal, because that's what my jig is made for. I can do it with 5/8, but then I have to grind that down a little bit right where that goes through that hole. So just heat up maybe about 3 inches of that. Now what I've done, I've got guides on here. These little pieces here are just guides, and that keeps it from wonking from either side. So it keeps that jig straight up and down, so it doesn't try to go to one side or the other. I was thinking about putting another spacer in here, that way I can make sure my piece is straight this way. So you want to make sure that you're not at an angle, anything like that. You want to be straight across so that you get the proper dip in there. Just hold that back right there. Now, don't get sprung. I'm just going to stick it through about yay far. I'm going to check make sure I'm straight across. I'm going to whack it. There's my offset. That's all I need. Now you do it the same way every time. And that's all the pieces. So let that cool off. Need to cut this off with the bandsaw. Normally what I do is I'll just take the grinder or file and round these edges off and make them, just give it a rounded end on it. So let me go ahead and do that real quick and show you all the parts. These are our parts. We've got a vertical, we've got a bottom piece, we've got a cross piece, we've got a ring, we've got a hinge piece. That's all our pieces there, so let's see if I can pick them up and hold them all at once. So that's what it looks like when you rivet it together. Alright. So really all the thing that's left to do is just clean it up and rivet it. And since it's after 11, I don't even want to do iron and a half. So I'll go ahead and I'll finish it up before I leave and we stick an iron and a half. And we're ready to go. That's it.
Appreciate it. Good job. Very good jumbo. We're going to do iron in the hat, and when the meeting's over, when Mike, if he wants to finish this, whatever you see, that's going to go in there.
Yeah.
So this will be one of the objects that's in iron in the hat. He's going to finish it out for us today. When we're through, some of you know Travis is moving from this shop back to his old shop, and I think he's going to open the doors up there and let everybody that wants to walk up and see it. Going to give a lot more room. It's a big shop. So he's going to move back up there, so you're welcome to hang around and we'll take a tour of it. Right now I think it's just a big open building. He's got a few anvils he's moved up there. But
Some of us remember working down there
yeah,
when we first started.
at some point that's where we'll be meeting. So looking forward to that.